Okay, so in this video we're going to go over a question that was posted in the group, that is from organic chemistry, that is the 2018 school certificate paper. Yeah, the paper that you are given in November, school certificate. GC is the one that is given in somewhere July or June, August. Yeah, somewhere there. Right, so we'll do more practice questions on organic chemistry to get a clear understanding on what the whole of the entirety of organic chemistry is all about at secondary level. Right, so the question says both that was C2. Okay, you are given 3 questions, section that's section C, to choose. Section A, multiple choice. Section B, you answer all questions. Section C, you answer 2 questions from the 3 options that are given. All right, so question C2 said both fats and proteins are natural polymers. Okay, and as I try my level best to remind you of this, when it comes to any topic, any subject that you are doing, when you're answering a question, it's very important that you understand what the question is all about. Where is the question coming from? And of course, we know this is organic chemistry, but what do we understand by because there are some few ways that have that have been brought in the picture here. You're talking about fats, you're talking about proteins, you're talking about polymers. What do we understand by this? Of course, I believe it's very simple for us to understand what fats and proteins are, but what do we mean by polymers? So when you're talking about polymers, if I just to give just a basic point for us to lean on to help us as we answer this question, when you're talking about polymers, these are just large compounds. They are large compounds. Okay, when you're talking about large compounds, when you're talking about the large compound, of course it comes in the picture to say how does this large compound comes about. So when you talk about a large compound, a polymer in this case, they are large compounds that are made from small compounds that are called what? Monomers. So we're talking about, for us to get a polymer, which is this large compound, you have to add up what? Monomers. Okay, so either adding 2 or 3, 4, so on and so forth. And another point that we need to keep in mind under would say macromolecules is that they are either they are what? Condensed polymers. Okay, condensed polymers, or they are what? Additional polymers. Okay, and you're talking about these, we have either what? Natural, as well as what? As well as synthetic. So when talking about natural, I believe we know what natural means. When talking about synthetic, it's just more like man-made, like the clothes that we wear, so on and so forth. The tents, the ropes, yeah, all those are what? Are polymers, but they are not natural polymers. They are synthetic polymers. They are man-made. They don't naturally occur. But if you talk about proteins are examples of natural polymers. Okay, and when you get to condensed polymers, what we mean by condensed polymers are those polymers whereby when you get their monomers, let's say you have monomer A, monomer B, you want to get this polymer, which is what? AB. Okay, you want to get this, or rather, let me say A, not really that. Let me say C plus what? C plus D. So let me just represent C and D as what? As one polymer. So when you get these two monomers, A and B, when you add them together, you get this polymer. Okay, so when talking about condensed polymer, what it means is that when you add A and B, water is going to be what? Is going to be lost. Okay, for us to get what? To get that polymer right there. That is what we mean by what? Condensed polymers. And when we're talking about additional polymers, they are just examples like from those beginnings, like the first 2 homologous series. You're talking about alkanes, as well as what? Alkenes. Adding those, like you get maybe an alkene. you get 2 or 3 alkenes, you add them together, what you're going to get is what? Is also a polymer. So those are called what? Additional polymers. Alright, so now I believe this information is enough to help us answer that question. If there's any that we haven't illustrated here, I believe it will manifest itself as we go through these questions. Okay, so the first question says, name the synthetic polymer that has the same linkage as 1, we have been given fats, 2, we have been given what? Proteins. So when talking about fats and proteins, these two we have been told they are what? They are natural polymers. So I want to find the synthetic polymers that have the same link as the fats as well as what? The proteins. So when you're talking about the link that is found in these two, the fats and the protein, without even wasting much time, the link that is found in fats is like this. You have oxygen there and you have another oxygen there. Then the one that is found in what? In protein, you have nitrogen here, you have carbon here, you have a hydrogen here, and you have a what? You have oxygen there. Okay, so what we have here, right? So what we have right here, this one is one that is called an ester link. Okay, so this one is called an ester link. So this is what? An ester link. And this is called what? An amide link, or it's called a peptide bond. Peptide bond. What we mean, like, is this is a peptide bond, of course. Like, the more you add the more, like, you are increasing the number of amino acids you are adding to get the protein, it determines how you are going to call that peptide. If it's 2, you are going to get what? Di. 3, tri, so on and so forth. Okay, so now we want to find the synthetic polymers that have the same linkage as what? The same linkage as fats as well as what? As well as proteins. So we have these two synthetic polymers. There's one which is what? Nylon, and there's another one which is what? Terylene. So when you talk about nylon, for us to get nylon, what we had to do is that we had to add a diamine, okay? Diamine as well as what? Dicarboxylic acid. Carboxylic acid. Alright. So when you add a diamine and a dicarboxylic acid, what you're going to get is what? What you're going to get is that. Okay. Then for us to get terylene, what we had to do is that we had to add a dialcohol, I'll just say di-OH, as well as a what? Dicarboxylic acid. That will give us what? Terylene. Alright, so when you add these two, maybe we try to give an illustration about on how this goes. We see which one will give us which link. Okay, so let's talk about, let's bring in nylon in the picture here. We say nylon. We say for us to get nylon, we have to bring in what? Diamine, as well as what? We say plus dicarboxylic acid. I'll just say COOH like that. Alright, because this is the what? The functional group for what? For the acid. So diamine, we know to say an amine has NH2. So when talking about diamine, we are just going to introduce a 2 there. Okay, so meaning even for carboxylic acid, we're just going to say 2COOH like that. Okay, so now for us to draw the structure, this is how it's going to be. We're going to have our nitrogen here, okay, linked to another nitrogen, meaning we have completed putting up the 2 nitrogens that were given there. Then remember to say this is a 2 here and that's a 2, meaning we have 4 hydrogens. We have one here, we have another one here, okay, we have another one here, and we have another one there. Then we say what? We add these plus what? dicarboxylic acid, we can say we put our carbon here, we put our oxygen there, okay, we put our OH here, so this is OO and the H. So remember to say we have a di, so we're adding 2, okay, another one here. So keep in mind to say don't forget to put a double bond on the carbon to oxygen. It's supposed to be a double bond, and you know to say carbon needs 4 electrons to have a what, a 4 atomos energy level. Hence you need to have what, 4 bonds. If you only put 1 here, meaning you're going to have something like carbon here 1 2 3. So it's like this is not the way to go about it. This is what, basically wrong. Okay, so now we know to say this is a condensed polymer, and we know to say water is going to be lost in the process. So we're going to get we are going to get a water molecule as a byproduct. Another water molecule is going to be lost in the process. So we have this hydrogen here and we have this hydroxide here. So we're going to get these two. These are going to be lost. Okay, we say this is what? This is lost. Then we have another hydrogen here, another hydroxide here. This is going to give us what? This is going to give us water as one of the byproducts that we need to get. So we want to say this is equals to what? So you know to say when we get this part, in this part we get it as a byproduct and we lose out this one. What you are going to remain with in this case is this. We are going to remain with this part here. This part like that. And here's how it's going to do what? To appear. We have our hydrogen here, we have our nitrogen, another hydrogen here, linked. Now the plus sign goes, of course, we have combined these two. We have a carbon here, we have a what? Oxygen, we have carbon linked to another carbon, oxygen there, plus what? H2O. So this is the what? The structure for what? For nylon. And if you look at this part, if you look at this part carefully here, the link that we have takes us back to what? This link is this one here that we have. So that's what? An amide link. And you know to say an amide link is one that is found in protein. So we can say, oh, okay, the synthetic polymer, the man-made polymer that has the same link as protein is what? Is nylon. We can say nylon here. We can put what? Nylon like that. So now it even gets to the answer to say the one that has the same link as fats is what? Is sterylene. But let's try to justify the answer just for the sake of understanding. Okay. Alright, so from the literature we know to say that for sterylene, the monomers are what? We have dialcohol, I'll just say diol, plus what? Dicarboxylic acid. Okay, so we're going to add these two. So meaning it's what? 2OH plus what? 2COOH. So we're going to have what? We're going to have O here. Okay, you're going to have O and the H linked to what? Another O, another OH. Doesn't really matter how you arrange this, it still means the same thing. Okay, plus what? I'll say C hydroxide there, the link, carbon, oxygen, and the hydroxide there. So remember to say this is still a condensation reaction, meaning water has to be lost in the process. So we have this hydrogen here, or rather this, I'll say this hydrogen and this hydroxide here. So we're going to get these two. We say these are the ones that are going to be what? That are going to be lost. That's the water molecule that we are going to lose. Then for this other part, we have what? We have a hydroxide here, and we have what? A hydrogen here. So this one is going to be we are going to get it as one of the product that is a water molecule. Okay, so here we have what? This will give us, so when we take everything out, what you're going to remain with is what I'm going to underline in white. Okay, so we have this part of course we have this part here, and we have what? We have that part. So the product is what? Is O linked to what? Another O here. Then this O here is linked to, we are going to link it to what? To the carbon there. Okay. We're going to link it to the carbon, the oxygen there, another link, the carbon, the oxygen there. Then of course plus what? H2O, the water molecule that we are going to get. So when you look at the link that we have gotten here, this link, this is a what? This link is the same as that link there, and that is the link that is called what? An Easter link. So we have now justified our answer. So keep in mind to say that whenever you are answering a question, you need to be confident in your question. It's just not the matter, whenever you're answering the question, you need to be confident in your answer. I mean, it's not just a matter of answering anyhow, because you need to know why your correct answer is correct, and why is the answer that you have put aside, why is it wrong. So you need to have those reasons, yeah, such that even as you go out of that exam room, you are sure to say what I had to put there was very much correct. Okay, so, and it just comes from us understanding the topic from the basics. Okay, organic chemistry is one of the simplest topic, I believe. Okay, so now let's get to question 2. Get to question 2 there. Okay, so question 2 says, draw the type of link found in the synthetic polymer named in A1 above, and name the link. Okay, looks like we have already answered the question here. We have already answered this question, I believe. So the link for A1, you know, to say A1 is for what? For pterylene. And the link we found was what? We have oxygen here, we have carbon, and that oxygen. So this is the structure that they want, and the name is what? It's an Easter link. That's an Easter link. Okay, so that's the answer for question B1. So B2, it says synthetic polymers are non-biodegradable. What is meant by this statement? So when you're talking about biodegradable, this just basically comes from us knowing whether this is able to decompose or not. It's more like you bury a plastic bag. There are some plastic bag whereby you bury, they are buried in 2000. You try to dig them out, you still find them just the way they are, meaning they are what? Non-biodegradable. Okay, if it's biodegradable, it's more like you bury something, after a while you go there, you won't find it anymore. Like, it's just there is like, it's like the soil, they're like the organisms that right there in the soil have just done the job, and like they have decomposed everything. Okay, so biodegradable, we mean non-biodegradable, we mean not the ability of not being able to decompose by any biological mean. That's what it means. So you can try to make your explanation as simple as possible, and if you can look at the marks, you only have 1 mark there. Okay, so far I believe we have our 5 marks. You're remaining with the other 5 marks. Let's see if we can get the other 5 marks as well. I believe we can. So question C says, the structure displayed below is for another natural polymer. Okay, say name this polymer. So without wasting much time, that polymer there is a carbohydrate. That polymer there is a carbohydrate. And of course, when you go in different books or go to a higher level, you're going to find that there are different ways in which we get these. It's more like let's say you have this sugar, which is what? Which is sucrose. So for us to get sucrose, we need to get glucose plus what? Plus fructose. Okay, so you find that in the structure for glucose and in the structure for what? For fructose, there will be a point where you're going to have a hydroxide on this side and another hydroxide on what? On this side. So now, at this level, they have only picked these. to give us a basic understanding of what the structures for carbohydrates are going to appear. But of course, the structure for glucose, we know it's very huge. We have carbon 6, hydrogen 12, oxygen 6 as well. Okay, so as you draw their structures, there is a point where you're going to have a hydroxide at some point. Even on the other side, you're going to have what? A hydroxide. Then when you combine those two, that is what you're going to get right there. Okay, so now we know to say question 1, say this is a carbohydrate. Say this is a carbohydrate. That's a natural polymer. So you say question 2 is asking, say, is this polymer an addition polymer? I mean an addition or a condensation polymer? Give a reason for your answer. So this is basically a condensation polymer. What do we mean? So it's more like we can bring in this part. We can get that, we link it to another hydroxide, we say plus another hydroxide here, we link it to the other one. You can add as many as possible. So you know to say what we are going to have here is that since this is a condensation reaction, this hydrogen here and this hydroxide are going to combine. That is the water molecule that is going to be lost. So you find that even this part, this hydroxide, and on the other side, so of course this one is combined with whatever is this side because we're just adding a lot of them. So even this part is adding with whatever is this side. So you find that the overall product that you're going to get is this. Is going to be in this manner. You're going to have let's say we get rid of this hydrogen here because of what is on the other side, meaning we are going to remain with what? Oxygen, with a bond there, the bridge. So you have another oxygen here, like that. It continues going on and on and on like that. So this is the structure that you see on that part. Okay, so this is why we say this is what? A condensation polymer, because a water molecule is being lost. Yeah, so when you give them to say, okay, now this is a condensation polymer, give them a reason. That's a reason. A water molecule is lost in the process, and what you're adding is that you're adding two like you're using dialcohols as what? As monomers, right? So say draw the structure of the monomer used to synthesize this polymer. So this is the structure that we have already drawn here. That's the structure that we have drawn, which is what? We have our OH there and our OH. This is what we have, right? So what type of link is found in this polymer? So for this polymer is it has a rather different type of link. Of course, from the first ones we saw to say we have an ester link as well as what? An amide link. But for this one we have what is called a glycosidic what? Glycosidic or glycosidic, depends on how you want to pronounce it, but that's the spelling. That's the spelling right there. Glycosidic. We would say glycosidic link or bond. It's still means one and the same thing. So yeah, that's how we go about answering that question. Yeah, I believe it was, you can say it was straightforward. It's just a matter of us understanding what the literature of the topic, I mean organic chemistry topic, talks about. Okay, so that's all from this video, and we'll try to pick as many questions as possible for us to gain more understanding on how to go about organic chemistry questions. Okay, and just in case you're watching our videos for the first time, we have a WhatsApp group. Like this question was just posted earlier by one of the members in the group. Okay, we have a WhatsApp group, and if you'd want to reach us, you can use any of these two numbers. There's this one, 0974004921, as well as what? 0965789745. Okay, you can text any of these two lines. You can either WhatsApp us or inbox us. You can choose any. Yeah, we'll be able to help out, and we'll be very glad to have you as part of the Transcended family. Yeah, so that's all from this video. Thank you.